Hello. Today we're going to talk about the gravity experiment. So first is the report format. So one, it should be the title. So you can say gravity experiment. You can say gravity estimate. Okay. So your design, okay, your design. And you get the title. Two is the objective. So you can say estimate G value in your neighborhood, right? Okay. Three, it would be the assumptions, hypothesis. So you can list your hypothesis. So for example, you can say, assume the G is constant, right? Assume G is constant in your area because your variation is not very big. And you can say that your timer, right? Your iPhone or your timer has accuracy of something, right? Maybe like a plus minus 0.1 second. I don't know, right? So C, things like that. Number four, material. So I would suggest, but it's your design, okay? This is your design. You decide what to do. So I suggest badminton birdie, right? Badminton birdie, right? 羽毛球. Okay, so 羽毛球, right? Because this one has a little bit of drag, but not too much. And B, I would say like a paper, right? Like a 8x11 paper, the A4 paper, right? So as I say, it's your design, okay? And C, I would say like a coin, right? So this one has almost no drag, right? Okay. All right, so that's the material. I'm gonna clear that. And number five, okay, procedure. Or steps, right? So this is your procedure, right? So I would think that maybe one, or A, you would measure, or you say select, right? Select the location for free fall, right? So you need to select at least two locations, right? So two, so say high, right? And medium, right? So I would suggest something like 3 meters if you can find it. And then here, 1.5 meters, something like that. As I say, it's your design, okay? So that's select the location, and then B, what do you do, right? So maybe you would just drop, right? You go and drop, right? Drop the object, right? So you have 3 objects, right? At least, right? So drop one of the object, right? And then when you drop, you may want to say like so here, obviously here, you need to measure, right? Select and measure the height, right? Measure the height for the location, right? And then you drop the object, and obviously you need to start the timer, Yeah, or have your parents or have your sisters or brother, right? Start the timer, right? And then drop, right? And 2, and then you drop, right? All at the same time, right? And then number 3, when it hits it, you stop the timer, right? Okay. So you can see clearly here you have some error, right? Some operator error can happen because your eyes is not perfect, right? And here too, right? You can see the heights that you measure. There's some error source right there too. Okay? I'm just giving you some hints, okay? But there may be other stuff. So that's the procedure, right? And you keep going, okay? And you design your steps. And number 6, the data measurement, right? So what do you measure? So you need to have your table here. So you want to say like a table 1, right? Right. So this is basically your object 1, right? And then what do you measure? So you maybe measure the time, right? The time duration, right? For the free fall, right? For the free fall. And then you measure the height, right? So those are the data that you measure. And then maybe there's something else, right? So you decide what you want to measure. So table 1 for object 1, and then table 2 for object 2, right? Right. And table 3 for object, right? For object 3, okay? So that's the data measurement. And then number 7, now you may want to graph, right? You want to graph or plots, right? Of your data. Graph, plot your data, right? Okay, so how you want to plot it, it's up to you, okay? So you know the why, right? So I mean, so early day, the scientist doesn't know this. And now you know this is the equation. But you need to pretend, right? So you need to pretend you don't know this equation, right? Kind of. So what do I mean by that? So like you don't know this is G and that's the G and that's the form right there. Right? So you may actually have something like this, like a CT square, for example, right? So you measure the time, you measure this height, and then you can go and figure out. So how do you do this, right? So what I would do is I would plot something like y is here, and then I'll plot t squared here, right? Remember it's t squared. And then this will be the slope, right? So then the slope here will become your c, right? So the slope here will be equal to your c, for example, right? Obviously, you don't have to do this. I mean, you can do, you know, so you got to have your label, right? So this should be in meter or centimeter, but you know, it's your choice. So this will be second squared, right? So you pretend you don't know this, okay? Like a 1/2 g, but you come up with a c anyway, and then you go figure it out, right? Go figure out, you know, I don't know how the early scientists figure out it's 1/2 g, right? So it's kind of your creativity here, how you want to do it, okay? So you pretend it, you go figure out what's the c, that kind of stuff, right? And then number A is the error analysis. Okay, so what's the source, right? So A, maybe your height measurement is not correct, right? Your height measurement is not perfect, right? It's is imperfect, and so you need to kind of tell your audience, which is me, right, that how imperfect is your measurement, right? So maybe one of the measurements is really bad. And B, maybe your time measurement, right? Your time measurement is because when you see it touch the ground, it may already pass, and maybe you press it too early, right? Too early or too late, right? So how much of error is that, right? That's up to you, okay? And then there could be other stuff, right? So obviously I want you to include the drag, right? So the drag is going to influence your data a lot, right? So this is very, very important, okay? So this is very important. You got to figure out what kind of drag. So usually drag, okay, I mean, it looks like a C1 and then velocity squared, for example, right? So it depends on what kind of drag model you have. So if you are indoor versus outdoor, obviously it may be a little different, right? So indoor and outdoor could be different. Okay, so what does it look like? You got to go do a little research. Okay, so this is where that's important, the drag, right? So I'm going to clear that. AC, right? So A, right? This is an error analysis. Maybe there's a D, okay? And what do you want to talk about? So maybe like your geometry of your object, right? Geometry and the texture, right? Texture of, right? Or you think that maybe the way, I don't know. It's, you know, it's your experiment, way of your object, right? So which one matter, you know, which one matter? So obviously, you know, this paper, right? This paper, it's going to have a lot of drag, right? And then coin, you know, I mean, they all have different weight, right? So this is weight 1 and weight 2. Weight are different. But is that the reason why you come up with different C, right? So you have this Y equal to CT squared. You know, so your C may be different, right? For your object 1, right? So object 1, you come up with a C1. So I don't know, CA, right? And object 2, you come up with no, C1, C1, okay? And object 2, you come up with C2, right? But why are they different, right? So obviously, you know, some of them are due to the drag and some of them are due to something else and some of them are due to your error, right? So you got to go and discuss those. So number 3, object 3, right? Okay. And number 9 is your observation and conclusion. Okay, so you can draw some conclusion based on what you see, based on your data, based on your error analysis, right? So you may want to say something, right? So like a small paragraph, right? Right. What can you conclude, right? Maybe you concluded the C in object 1, 2, 3, they're very similar, right? Depends on the object that you chose. But don't choose like a 3 coin, for example, right? Or choose like 3 pieces of paper, right? That would not be a good idea, right? At least you got to have 1 paper and then the other one maybe you fold it, right? You fold it like, you know, a few times and now it becomes smaller and more stiff, right? And then, so you want to pick something that has a lot of drag, right? Big drag, and medium drag, right? And then, you know, negligible, right? Very, very small drag. Okay, so then it will become more interesting. Okay, so that's some suggestion for you. And it's due on Wednesday, right? So you got to write your report and do an experiment and come up with all the data, table, plots, and doing the analysis. Okay, bye-bye.